Imagine this. Without touching your hands, your phone, or any device at all, you can turn on the lights just by thinking about it. Or maybe you're sitting down, sending a message, starting a game on your computer, or even moving a robot using nothing but the power of your mind. In the past, we would have called this science fiction. But now, in labs and even some hospitals, this technology is becoming a reality. So, is it truly possible to control the digital world with just your thoughts? How are we making this happen, and what does the future hold for us? Brain-computer interfaces, or BCIs, refer to groundbreaking technology that allows people to control computers, robots, or digital devices using nothing but the power of their thoughts. In recent years, developments in this field have made it feel as though scenes from science fiction are being brought to life. Yet the origins of this technology actually date back to egg experiments in the 1970s, pioneered by Jacques Vidal. These early studies proved that electrical signals from the human brain could be captured and interpreted by a device, laying the foundation for today's neurotechnology revolution. Now, BCI technology is not only found in laboratories, but is being used successfully in real-world clinical applications. The human brain's hundreds of billions of neurons are in constant communication through electrical signals. And specific patterns of these signals are linked to actions like movement, speech, and even thought itself. These signals can be measured using non-invasive methods, such as EEG, where sensors are placed on the scalp, or with microelectrodes implanted directly into the brain tissue. Non-invasive methods are widely used because they are safe and painless, while invasive techniques provide higher precision and more detailed data, albeit at the cost of requiring surgery. Regardless of the method, the goal is to capture the brain's electrical waves and transfer them into the digital world. But for this raw data to become meaningful commands, highly advanced machine learning and signal processing algorithms are necessary. Because each person's brain structure and signal patterns are unique, these systems must be trained for every individual. When a user imagines a certain movement or action, the system detects this unique electrical pattern and converts it into a clear command to be sent to a computer or other device. This means that someone can write a word just by thinking about it, move an object on a screen by focusing their attention, or even control a robotic arm with the power of their mind. The real-life impact of this technology becomes more impressive every year. For example, in a 2021 study at Stanford University, a person with spinal cord paralysis who could not use their hands was able to write at a speed of 90 characters per minute simply by imagining moving their hand, thanks to a brain implant. This stands as one of the most striking and concrete examples in the history of science of thought being transferred directly into the digital world. Another breakthrough came with Elon Musk's Neuralink initiative. In a 2021 video, a monkey with an implanted device was shown playing a video game entirely through the power of thought. Such experiments, not only with humans but also animals, demonstrate the immense potential of the brain's electrical activity. In 2022, another brain implant developed by the company Synchron enabled a paralyzed patient to post on Twitter and send WhatsApp messages simply by thinking. These success stories from labs show that BCI technology has now crossed over into actual clinical use. Despite such spectacular advances, there are still significant challenges that need to be overcome for BCI technology to reach its full potential. With non-invasive methods like EEG, signal quality is low and vulnerable to interference from external noise. Invasive implants, on the other hand, carry the risks of surgery and long-term biocompatibility. Moreover, the complexity of brain signals, which vary from person to person, makes the process of decoding commands through machine learning more difficult. Every user needs their own training and calibration process. Furthermore, current hardware is generally large and expensive, and there is still much progress to be made in terms of miniaturization and portability. Engineering problems such as energy consumption and wireless data transmission also remain to be solved. Security and ethics are other major issues facing BCI technology. Data gathered from the brain is considered medical data and is highly sensitive in terms of privacy, requiring strong legal protection. In the United States and Europe, these kinds of devices need approval from organizations such as the FDA before they can be widely used in people. Collecting and analyzing brain data without user consent is neither ethical nor legal. Today's BCI systems do not have the ability to read minds without the user's explicit participation or without them consciously focusing on a command. In other words, secret thoughts, memories, or unconscious images cannot be read with current technology. Even so, the benefits BCI technology provides in medicine are incredibly striking. For people who are paralyzed or who have conditions like ALS or spinal cord injuries, being able to communicate, write, control robotic arms, or operate digital devices just by thinking can be life-changing. And it's not just in health major. Changes are on the horizon in the digital world as well. In virtual and augmented reality applications, hands-free control with BCI offers a completely new kind of experience, while in gaming, the idea of moving characters or objects using only your thoughts opens a whole new dimension. In education, students' levels of focus and attention can be tracked in real time. Via brainwaves and learning processes can be personalized accordingly. Military and industrial applications are also being explored. In military technology, controlling drones or robots with the mind, and in industry, achieving new levels of precision in tasks that require close human-machine cooperation are both in the works. In all these areas, BCI stands out as an extension that surpasses the biological limits of humanity. But it is important to stress again, brain-computer interfaces are not yet the magical devices from movies that can read everything we think or give us superpowers. For now, they function primarily as systems that can recognize individual, controlled commands when the user consciously focuses on a specific task. The future vision for BCI is ambitious. Major technology companies and startups are investing billions of dollars to make both invasive and non-invasive BCI devices practical, safe, and accessible to everyone. It's not just about medical rehabilitation anymore soon. Everyday actions like sending a message, turning on music, or browsing. The internet might be accomplished through thought alone. Smart homes, wearable technology, and digital assistants could all be taken to a whole new level with BCI. Yet for this major transformation to happen in a healthy and ethical way, data security, user privacy, and societal acceptance will be just as important as technological progress. Today, brain-computer interfaces are a scientific reality in laboratories and some clinical applications. The transformation of thought into digital commands is no longer just a dream. It brings a whole new meaning to human life at the intersection of medicine, engineering, and artificial intelligence. With every new advance, both hope and excitement are growing, and it would surprise no one if this technology becomes as common in the next 10 to 20 years as smartphones are today. It must always be remembered that brain data is the most sensitive and valuable digital trace of a person. So ethical, legal, and social standards must develop in parallel with technological progress. Interacting with the world using the power of thought is closer than ever in human history. In the near future, we may be able to turn on the lights in our home, send a message, or even encounter new technologies we can't yet imagine, all with a single thought. But on this journey, it is up to all of us to be careful, informed, and responsible. What do you think about this technology? Would you want to control a device in your daily life using only your thoughts? Or does the idea make you a bit uneasy? Be sure to share your opinion in the comments. And don't forget to like the video and subscribe to the channel for more in-depth tech content like this. Your feedback and support help us produce even more quality content on this channel. See you in the next video.